Doesn't it seem like elementary math standards are more complicated than they need to be? It feels like there's too much to cover in each year, and sometimes the ideas are so dry and complicated that it's really hard to get students excited to learn math. Now, it's hard enough when students start the year on grade level, but if you have to address gaps from students who didn't do well in a prior year, who had an extended absence, it can feel impossible to get through everything that you need to cover. If you've experienced any of these challenges while trying to teach math to your children or your students, you'll want to watch this next video. I'll be going over the why, the what, and the how of elementary math standards. Why it's important to understand the standards, what the big idea, most important standards are in elementary math, and finally, how you can use your new understanding of elementary math standards to make the experience of learning math more fun, engaging, and impactful for your students. Why is it so important to have a familiarity with standards when we're teaching math or helping our children with their homework? Well, when we don't know the standards ourselves, we have to rely on somebody else's interpretation of those standards. And that usually comes in the form of a textbook. Textbooks are not really designed to be the most engaging, creative, or even efficient way to cover content. When a textbook maker makes a book, they have to make sure that there are lessons for every day and entire school year. Even if they thought they could cover the content in, 20 lessons, no school would buy a textbook that only has 20 lessons into it. So they stretch it out. They cover every possible angle. They give options for students that need extra practice. They try to include options for enrichment. At the end of the day, this can just become a little bit overwhelming. You see a textbook and you're like, oh, fourth grade math, I have to get through hundreds and hundreds of pages. When we know the standards, we can focus on where we want students to get to, as opposed to what we want to get through. Okay, that achievement, that competency-based approach is so much more effective, so much more interesting. Your students are going to get a lot more out of it in a shorter period of time. Here's another way to think about the granular approach that a lot of textbooks take. I often talk about what it would be like to learn about a car by taking it apart into pieces. You could take the entire engine apart, find every washer, every gear, and you could teach somebody what each of those pieces was for or what it was called. But would that person really understand what a car was, what the purpose of a car was, and maybe how to make or repair one on their own? Well, of course not. If you really wanted a better understanding of what a car was, you might drive around in one. You might figure out, well, what do people use cars for? You might even want to look at an engine as it's running so you could see how the parts interact with each other. Eventually, you might zoom in on an individual part of the engine. You might want to learn more about the cooling system or more about the head gasket or something like that. And then it would make sense to maybe take those pieces apart. But it wouldn't be the first approach. But that's exactly how textbooks approach math. We don't look at how do all these ideas interconnect. We don't look at why are these things important. We break them down into the tiniest little pieces and then we go through them sequentially. But when we know the standards, we can do three things. First is we can emphasize connections. There may be a standard about multiplying numbers and another about dividing numbers. Well, instead of considering those as just two separate activities, we want students to see that they're flip sides of each other. The same goes for connecting the ideas of numbers and operations. We might have one standard that talks about understanding the meaning of a fraction, and then another that talks about multiplying fractions, and another that talks about dividing fractions. But if our students already know how to multiply and divide whole numbers, it makes a lot more sense to introduce the idea of a fraction and then connect that to what they already know about multiplying and dividing whole numbers. Emphasizing those connections makes the learning experience both more interesting and more efficient. Efficiency is the second reason why it's important to understand standards. When we can connect standards and combine multiple standards into a single lesson or a single unit, students are capable of learning the big idea math standards in a much shorter time period than a full school year. Once we look at the big idea standards, you'll see how. And finally, learning about standards is a great way to transfer ownership to students. Students are much more motivated when they can take ownership of their learning. One thing we rarely do in schools is actually teach the students the standards. So at the beginning of third grade, students should get a list, or we should go over what are all the standards from third grade, and then they can actually reflect along the way when they've mastered each standard. Again, this is only possible when you as the teacher or the parent really knows what the important standards are. So the first thing to realize when we talk about elementary math standards are that there are two types of standards. There are the practice standards, or standards for mathematical practice, and there are the content standards, which are your grade level standards. In this section, we're going to focus on the content standards, the grade level standards. The practice standards are great, they're very important, but they're more about the how of math, right? They're things like model with mathematics, reason abstractly. These are the same from kindergarten through 12th grade. What you're probably thinking about when you think about elementary math standards, they're the grade level standards. Now, these grade level standards are organized into 5 domains: numbers in base 10, operations and algebraic thinking, numbers as fraction, measurement and data, and geometry. The numbers in base 10 standard is just like it sounds. The idea of getting students to understand what numbers mean and the fact that we use a base 10 number system. A base 10 number system means that the way we write numbers is organized around tens. So the first thing students do in kindergarten is to start counting, because first you need to know 1, 2, 3, 4, 5, and so on. Then they learn to make a 10. So we might give them 7 objects and they need to get 3 more, and then they need to write numbers up to 20. By the time students get finished with elementary school in 5th grade, they need to be able to represent numbers by multiple digits, thousands, 100,000s, millions, and so on. And they also need to go the other direction of breaking numbers into decimals and representing tenths, hundredths, thousandths, and so on. They need to use place value strategies, such as the traditional algorithm or stacking, to add, subtract, multiply, and divide. So if they can do those 4 operations with really big numbers and really small numbers like decimals, then students have really mastered the number in base 10 domain for elementary school. The next domain is operations and algebraic thinking. In this domain, students are thinking about the meanings of the operations and developing a more abstract understanding of number. Right? Understanding that subtraction is the opposite or the inverse of addition. Understanding that multiplication is repeated addition. Students start their operations in algebraic thinking in kindergarten simply by moving objects, grouping objects together to represent addition, separating objects to represent subtraction. By the time they graduate in 5th grade, they should be able to understand the connections between all 4 operations. And then there's the algebraic thinking component. Algebraic thinking is not just about algebra, but there are really 2 ideas that are central to algebraic thinking. One is the idea of equality as balance, and the other is the idea of variables. So to represent both of those ideas, I put a very simple equation on the board. 3 plus box equals 11. So here with box, we have the idea of a variable or an unknown number, right? So basically what we're saying here is that 3 plus some number equals 11. Now this can also be represented as subtraction, right? If we have 11 and we take away 3, we're going to get this mystery number here, which is 8. But to perform that algebraically, we represent it as an equation. The equation's in balance. If I take away 3 from this side of the equation, I have to take away 3 from this side of the equation to keep it balanced. So by 5th grade, if students can do something like this or a similar equation with multiplication and division, then they're proficient in that operations and algebraic thinking domain. They should also be able to use some of the vocabulary, like recognizing this as an expression and recognizing this whole thing as an equation. The third domain is the NF domain, which stands for number as fraction. Now, there are no NF standards from kindergarten through grade 2. NF starts in 3rd grade, where students need to understand the meaning of a fraction. So the idea of a fraction builds on the idea of division, but now we're breaking a single whole into multiple objects, right? So if I divide 1 by 3, I get 1/3. So students need to understand what it means to break something into equal groups, and they need to understand the idea of a numerator and a denominator, really to be proficient in 3rd grade fractions. By the time they graduate 5th grade, they should be able to perform operations with fractions and mixed numbers. A mixed number is a fraction combined with a whole number. They need to be able to add, subtract, multiply, and divide in a way, but they don't need to divide a fraction by a fraction until they get to middle school. By the end of elementary, they should be able to divide a whole number by a fraction. If they can do all those things, they've mastered the number as fraction domain. The 4th domain is MD, which stands for measurement and data. Now, this is a pretty tricky domain, partially because there's a lot in there. Measurement and data are really 2 different things. The thing that makes this domain important is that it's really the part where we get students to apply what they're learning about numbers and operations to real-world scenarios, right? They're measuring things. They might measure their own height, and then the data component could be where they measure the height of everyone in the class and then plot that on a graph. So the data piece has a lot to do with representing data through bar graphs or through dot plots. So the MD standard starts in kindergarten when students will measure objects and recognize that, 3 doesn't just have to be a quantity, right? Like 3 separate apples as opposed to something that can be 3 inches long. So that's an important mathematical concept. And then they start to organize and sort things, right? Like sort these items by longest to shortest or something like that. That's where we start getting the data component. Eventually, by 5th grade, students are supposed to be able to understand units and convert units, maybe go from feet to miles or centimeters into meters in order to solve problems. And they're also expected to represent data by graphing in the coordinate plane, by representing a bar graph, or representing what's called a dot plot. The 5th domain in elementary school is geometry. And like measurement and data, this is kind of the forgotten domain. Those 2 are forgotten because they're not very heavily tested. A lot of times they come at the end of the textbook and we don't really get to them. Geometry isn't really heavily tested until later on in middle school. So students start in kindergarten by recognizing simple shapes, squares, circles, rectangles. But by 2nd grade, they're supposed to construct and name different polygons with multiple sides, understanding the word polygon, which is a little complicated. They're also supposed to find the area of rectangles. They're supposed to find the areas of composite shapes, so a shape that has like a weird shape. It's not a square, it's not a rectangle, but they have to break it down into pieces and measure it. I find very few students actually come out of elementary school proficient in those things. I mean, it'd be a nice thing for them to have, but it does tend to fall by the wayside. They also, by the time they graduate 5th grade, they should be able to name different types of triangles, measure angles, compare different types of triangles, and just realistically, I see very few elementary students proficient in these areas. In fact, when students are in middle school and I do an elementary assessment of them to see, what strengths do they have and what are they missing, almost universally, students are unable to categorize quadrilaterals. So telling a trapezoid from a rhombus, from a rectangle, or describing the features of a rectangle or a rhombus, very rare for students to have mastered that. And to be honest, they don't use it that much in middle school either. So I would say the geometry standards are interesting. They're great for enrichment, but if you're worried about coverage, or you're worried about, is my child on grade level, or you're worried, are your students ready, I would really de-emphasize the geometry standards and focus primarily on the numbers in base 10, operations in algebraic thinking, and the numbers as fractions. So the big question, of course, is how can you use an understanding of standards to improve teaching and learning? Now, the first way is to create a backwards design curriculum plan. This idea comes from the seminal curriculum planning textbook called Understanding by Design. The basic idea is that you start with the objective. What do you want to accomplish? what evidence, how do we know that that objective has been accomplished? How do we know that the student has learned what we want them to learn? And then create learning activities that help them reach that standard. Now, when I work with schools to design their curriculum, we start broadly by creating a school-wide objective. What do we want our graduating student to look like? What do we want our graduating student to be able to do? Then we go back to what's the incoming student able to do, and that is our plan for learning. We then break that down by grade level and create objectives for each grade level, and then the grade level teachers create unit objectives. Okay, by thinking in terms of school-wide objective, yearly objective, and unit objective, that's how we focus on where we want to get to rather than where we want to get to. We want to be planning school, year, and unit as opposed to getting caught up in daily lesson plans or just planning right out of the textbook. The second way that understanding standards can improve teaching and learning is by our ability to combine standards. I mentioned earlier the idea of combining some measurement and data standards with some of our number standards. Instead of treating units as a completely separate activity, when we're teaching students addition and subtraction, just throw in units. Make it a word problem where a student has 2.5 gallons and adds another gallon and a half to the mix. How much do they have? Then we're already combining the idea of measurement and data with the idea of what we want students to be able to do with numbers. That relevance not only makes it easier to understand, but it makes our coverage more efficient. So another way that understanding standards can make our coverage more efficient is the ability to combine standards within a domain. So in most textbooks, we'll teach students about fractions first, right? What is a fraction? How do we compare fractions? How do we convert fractions? Then we'll have a chapter on adding fractions, a chapter on subtracting, a chapter on multiplying, a chapter on dividing. Well, if we've done the work well with our operations and algebraic thinking, students should understand what addition means and that it's the opposite of subtraction. So all we need to teach them is what a fraction is and how a fraction works, and they should be able to derive some of that knowledge. Same thing with multiplying. They can understand multiplication as repeated addition. When we combine standards in that way, it makes a lot more sense to students. They can see the connections between the standards instead of seeing each standard as a separate lesson or separate unit. And finally, the best way that we can use standards to improve teaching and learning is to actually teach the students the standards. So when I provide coaching and consulting to schools, one thing I notice is that a lot of teachers don't have a deep familiarity with their standards. Maybe about half of teachers probably could really tell you off the top of their head the standards from their grade levels. But when I go to the level of students, I would say almost none of the students I encounter know the standards of their grade level. This is a travesty. If you're in 4th grade, one of the first lessons of the year should be, here are the standards from 4th grade. When we present students with the standards, you'd be amazed at how much they can actually take the ball and run with it. There's a project I love to do where I just give students a standard and then give them a series of guiding questions, right? Like, what foundations do I need to master this standard? How will knowing this standard make me more successful in the world outside of school? What are some problems that would demonstrate whether or not I know this standard? So if I give the student a standard and those guiding questions, they can use resources. They can go online, they can do Google searches, they can watch videos, and they can figure out a lot of those things themselves. When they've gone through that process, either individually or in a small group, and they come back and they present on a standard, they're going to have much deeper mastery. And you'll also notice that if you can find the 10 or 12 major standards from your year, students can really master those each in a matter of days. That makes your life a whole lot easier, and it makes their learning much more effective. So I hope you've learned something new about elementary math standards from watching this video. Now, if you were paying attention, you probably are ending up with more questions than answers. This was a really brief tour, but you probably want to go deeper to better understand the standards from your grade level. One tool that I've designed for this purpose is the Math Standards Cheat Sheet. I've read through the standards, I've picked out what's most important, I've bolded the focus standards, and I've really summarized and put the standards into plain language. You can go to our website and download this cheat sheet for free. I'll put the link in the show notes, but it's going to be roomtodiscover.com/elementary cheat sheet. Another amazing tool that you're going to want to check out is the Achieve the Core Coherence Map. You can find this at achievethecore.org. What the Coherence Map does, it's an interactive, searchable guide to the standards. You can look at all the grade levels. You can zoom in on your grade level and see what the available domains are. Then you can go into each domain, see the standards, see which are focus standards. And if you click on an individual standard, you can map out what are the foundational skills for that standard, what future standards are supported by that standard, and it even gives you example tasks. So if you wanted to do that project where you assign students a standard and they have to come back and find out all that crucial information, they could find almost all that information by going to Achieve the Core themselves. This is a great way to build student ownership and really let them drive the learning. And final resource you may want to consult is just the Room to Discover website. On our blog, we have articles about curriculum planning. We have articles about specific math topics and how to teach them most effectively. You'll also find workshops on math topics as well as workshops on how to plan your curriculum. And finally, you can even schedule a private session to work with one of our curriculum experts to help plan lessons for your classroom or for your school. So thanks again for watching. If you enjoyed this video, don't forget to hit like and subscribe to the Room to Discover channel so you'll be notified as soon as we publish a new video about education.